In this video, we're going to be going over an example of how to do a stoichiometry calculation when solutions are involved. So just as a quick reminder here, we're still going to be following the same 4 steps to any stoich problem here, which is step 1, write a balanced chemical equation. Step 2, find the moles of your given substance. Step 3, use your mole ratio to convert moles of your known substance to moles of your unknown or your wanted substance. And then step number 4 is going to be to answer the question here. So I'm just going to take a moment just to write out those 4 steps. So there they are. If you want to pause this video and write them down for yourself as a reminder here. With this example here, it says what mass of zinc will react with 100 milliliters of a 0.1 mole per liter phosphoric acid solution here. Okay, so when we're asked, okay, what mass of zinc will react, so we know that zinc is going to be a reactant and it's reacting with phosphoric acid. So that's how you know that these 2 substances that we've been given, those are our reactants, because we're saying, hey, this substance is reacting with this other substance. So that's how you know. So zinc solid plus, so phosphoric acid. As a quick reminder here about acids and the naming system there, there's a few different sentences that we can use to help us remember how acids are named and how to translate that into a formula. So I'm going to take a quick second to write all of those out. All right, so here's the 3 sentences that can help us remember how acids are named and how to translate them into a formula. So with the first sentence here, I ate something icky. So essentially, if your polyatomic ion ends in ATE, then the acid name is going to end with ic and then obviously acid. Okay, so if the polyatomic ion ends in ate, the acid name is going to end in ic acid. For the second sentence, that's another reference to polyatomic ions. So if your polyatomic ion ends in ite, your acid name is going to end in OUS, acid. Okay, so these 2 are for polyatomic ions. So hydrogen is paired with some polyatomic ion. Whereas for the last one, if your ion ends in IDE, then the acid name is going to begin with hydro and end in ic acid. Okay, so this last sentence is referring to when you have hydrogen with only one other element. Okay, so looking at our acid name, phosphoric acid, so that's going to deal with this first sentence here. So the first sentence here tells me that I'm looking for a polyatomic ion that ends in ate. So we're going to just replace this, and this is going to be phosphate being our polyatomic ion. Okay. So if we take a look at our data booklet here, phosphate, we can find it right here. So that's PO4 with a 3 minus charge. And we're going to add enough hydrogens to balance out that 3 minus charge. So because hydrogen typically likes to have a +1 charge here, we're going to add 3 hydrogens to balance out the 3- charge of phosphate. And then acids are always going to be aqueous. Now for our products here, so if I look, we got an element reacting with a compound. So this is a single replacement reaction. So we're going to want to figure out what type of ions our element likes to form. So one way you can do that is you can say, well, I know this is a metal, and metals typically like to form cations or positive ions. Or you could also just look it up on your periodic table, and zinc is going to be number 30. So right here, and you can see that it likes to form a cation. Okay, so that means that since zinc likes to form a cation, it's going to switch with my other substance that likes to form a cation, which is going to be hydrogen. Okay, so essentially what we're doing is zinc and hydrogen, they're just going to change places here. So that's going to give me hydrogen. Now remember, hydrogen is part of Hofbrinkel, which is all of our diatomic elements. So whenever it's by itself, there's always 2 of them. Hydrogen is going to be a gas at room temperature. You can always check that out on your periodic table. So hydrogen is blue, and if we look at the key, blue means that it's a gas. Okay, plus, now we said that zinc was going to take the spot of hydrogen, so zinc, phosphate. So remember, zinc likes to have a 2+ charge, phosphate likes to have a 3- charge. We know that this doesn't equal 0, so we're going to have to do crisscross applesauce. So that's going to be, we're going to have a 2 after phosphate, and we're surrounding it with brackets because whenever you have more than one polyatomic ion, you always surround it with brackets, and then 3 coming after zinc. Okay, so now that compound's balanced, and we'll need to check the state of this. So let's see. All right, so I'm finding phosphate here. Remember, for using this table, you always find your anion or your negative ion first, and then your cation or your positive ion second. Okay, so phosphate's here, and it says, okay, anything that's a group 1 ion or ammonium with phosphate is going to be very soluble. However, if we take a look at where zinc is, so zinc is number 30, it's group 12, so it doesn't fit in those group 1 ions there. So that's going to mean that it doesn't fit here, it's not ammonium, so it's going to be insoluble. All right, so now we have our skeletal equation, and now we need to balance it. So because zinc and hydrogen are by themselves here, I'm going to leave them till later, and what I'm going to do is I'm going to balance phosphate first. So I've got 2 phosphates coming out, so I need 2 phosphates going into this reaction. Okay, and so phosphates are balanced. Now that 2 didn't just affect phosphate, it also affected the hydrogen. So now we have a total of 2 times 3, so 6 hydrogens here. So I'm going to make sure that there's 6 hydrogens on my product side. Okay, and last but not least, we're going to worry about zinc. So there's 3 zinc coming out. We got to make sure there's 3 zincs going into the reaction. And that's balanced. So that is step 1, balanced chemical equation, finished. Now I'm just going to organize some information that we've been given before I move on to step number 2. Okay, so it asks us what mass of zinc. So mass of zinc, we have no clue. And whenever we see mass, we need to figure out molar mass of that substance. So for zinc, the molar mass of that is going to be, 65.41. And that's grams per mole. Okay, and then it says that we're reacting with 100 milliliters, so volume is equal to 100 milliliters of a 0.1 mole per liter. So this, because the units are moles per liter, that's how I know it's concentration. Now, if I look at my units for phosphoric acid, one of them is in milliliters, and the other unit in concentration, that's kind of close to that, is liters. So I need to make sure that the volume units match up. Okay, so what you can do is you can remember the metric conversion line, which I'll write it all out. Okay, so these letters that I've written here, they're all the letters that are to denote the prefixes. So starting on the far left-hand side, T is for tera, G is for giga, M is for mega, K is for kilo, H is for hecta, DA is for deca, D is for deci, C is for centi, little m is for milli, and then this symbol here that kind of looks like a U is for micro, nano, and then pico. Okay, base units are just whatever unit that does not have a prefix with it. So something like grams, moles, liters, so on and so forth. Okay, all of those are base units. Now, if we look here, the easiest number to convert is going to be the number where the units they're not a fraction. Okay, these units are a fraction, whereas milliliters is not. Okay, so that means this is going to be easier to convert. Okay, and how I'm going to do that is I'm going to be like, okay, we're starting at 100 milliliters, so I'm putting a dot where milli or milliliters would be, and I know that liters would be a base unit because there's no prefix to it. So then I count starting with where I'm starting at, milliliters. So 1, 2, 3. So that means we have to move our decimal 3 spots over to the left. So 1, 2, 3. So volume is going to be 0.1 liters. Okay, so now that we've got that all figured out, now we can go over to step 2, which is find moles of the given substance. So the substance we've been given the most information for is phosphoric acid, so that's where I'm going to start. Now, I notice that we have volume, we have concentration, and we're looking for moles. So if I go to my formula sheet, I'm noticing that, okay, I said we have concentration, we have volume, we're looking for moles. So since there's only one variable here that we don't know, this is a great formula to use. We're not going to use this C1V1 is equal to C2V2 or CIVI is equal to CFVF because we don't have 2 volumes and we don't have 2 concentrations. Okay, so this is the formula that we're going to be using for this calculation to start off with. So concentration is equal to moles divided by volume. but we want to get moles by itself. So we need to ask ourselves, okay, volume, what is it doing to moles? Well, it's dividing. So the opposite of division is going to be multiplication. And what I do to one side, I need to do to the other. So we have this because volumes cancel out. And this is going to be the formula that we're working with. All right, how much space do I got? Okay, we're good. So I'm just going to flip around this equation because I like to have my unknown on the left-hand side. Now for volume, we said that was 0.1. And then concentration, that was also 0.1. Okay, so notice how liters is in the top and the bottom, so they cancel out. So then if I go 0.1 times by 0.1, it's going to give me 0.01. And because both of these numbers belong to phosphoric acid, I know that I just found the moles of phosphoric acid. Okay, so that's step number 2, find moles of given, done. Now we're on to step 3, mole ratio. So let's use a different color here. So mole ratio, in the numerator, we want to have the substance that we want, and then in the denominator, the substance that we're given. Okay, so we're given phosphoric acid, and we want zinc. Okay, so the coefficient in front of zinc is 3. The coefficient in front of phosphoric acid is 2. Okay. So if I take my 0.01, times it by 3, divide it by 2, we get 0.015. And that's going to be our moles of, so phosphoric acid, if you treat it like a unit, phosphoric acid's in the top and the bottom, so they cancel out. So this is now moles of zinc. All right, step number 4, answer the question. Well, what did the question ask us? It asked us for the mass of zinc. Okay, so at this point here, our formula is mass is equal to moles times by molar mass. Okay, so here we have moles, and we already figured out that molar mass was 65.41. So we're just gonna keep on keeping on. So 0.015 moles, so this is of zinc, and then we're using our molar mass of zinc because these have to come from the same substance. All right, so 0.015 times by 65.41, and that's going to give us 0.98115. And for our units, well, moles is in the top and the bottom, so they cancel it out, so this is in grams. All right, so with SIGDIGs, it looks like the two numbers that we were given, they're both in 3 significant digits. So as a reminder, leading zeros do not count as significant, but trailing zeros and any digit that isn't 0 do count as significant. Okay. So 3 SIGDIGs. So if I count from the far left, remember leading zeros don't count as significant. So 1, 2, 3. There's my cutoff line. So my answer is going to be 0.981 grams of zinc. Okay, so again, there's only one example for solution stoich, and it's just because we're still following the same 4 stoich steps that we've been doing previously here.